So on to our next calculation. And this calculation is going to be standard deviation. So if I look at standard deviation, it says it measures how closely the data is clustered around the mean. Smaller standard deviation, more data around the average, means better precision. All right, so let's look at standard deviation and really talk about what it's trying to tell us. First, this is one of the major ways that we show the term precision. So again, remember you at the dartboard and you're throwing the darts at the dartboard. How close are your measurements? Right? That is the definition of precision. How can we apply that definition to a mathematical concept? That is where standard deviation comes in. So very often, if you are required to do a lab experiment more than once, meaning that we're giving you a sample and we're making you process that sample 2 or 3 times, we are going to be asking for an average, and you report that average. And then on the grade sheets for the labs, you're going to find out there are points going to be assigned for standard deviation, and it will give you a cutoff value. Well, those cutoff values can change depending on the labs, depending on what kind of samples that you're doing and that you're processing. But how do we calculate that standard deviation? That's the question. What kind of equation are we using? What kind of math is going on behind the scenes to calculate this magic number for you? So standard deviation is precision. What you will find out is that the lower the standard deviation, and that's my abbreviation for standard deviation, STDEV, lower standard deviation means better precision. That means that all of your darts are clustered together on the dartboard. All of your samples that you are processing are coming out very close to each other. So low standard deviation is much better than a higher standard deviation. So that's what we strive for. Low STDEV numbers, low standard deviations. All right, so in the PowerPoint, you are going to be looking at a standard deviation equation. And this is the equation that you will find. It's a horrible looking equation with a lot of variables in it. But again, let's take it piece by piece and let's talk about what these variables mean. So the very first one that we're going to look at is the term S. And S is equal to standard deviation. That is what that means. STDEV. So S is equal to something. All right, in the next part of the equation, you're going to find this very large square root symbol. Square root signs are very common on calculators. If you've not talked about square roots before in math, you will get to that point. For us, we just need to know where that symbol is on the calculator so we can use it. So there's my standard or my square root symbol. Up here at the top, I see another E. Well, the E was always just like it has been. E basically means summation. I'm going to be adding something up. Okay, well, what am I going to be adding up? Well, here it says x sub I. All right, so I know what x sub I is. X sub I is my individual data point. I learned that from my average. So that definition has not changed here either. I take the individual point that they're giving me, and then the standard deviation is going to say take your point and subtract x bar from it. Well, what was that x bar? Well, x bar was the average. So I'm going to take the individual point, subtract the average, and then standard deviation says you square, raise it to the exponent of 2, not multiplied by 2, you raise it to the exponent of 2. You square that difference. Then when you do that, your job's not done, because down here it says you're going to then divide by n, where n is the number of data points, just like before in the average, minus 1. Okay, so there's quite a bit more to do with standard deviation. Let's work out an example by hand, just to show you how nasty this can get. All right, so let's take our previous example here. We had this data set, and I'm going to go back and I'm going to delete this median 2 and the number that goes with it, and I'm going to delete this 118. So this was the original set. And let's say that I'm required to do the standard deviation of this set of numbers. What is the precision that was associated with this? Is it close? Is the precision really good? Is the precision really bad? Is the standard deviation a low number or is it a high number? Okay, so this is what I'll do. First off, with all standard deviation calculations, you have to know the average, right? That's embedded into the equation. Well, the good news for us is that we know what the average is. It's right here. So my average is 108.6. So I'm going to come over here and I'm going to say, okay, my average is 108.6. That way I won't forget it. I've got it on my sheet of paper. I can do the calculation with it. Okay, so it tells me in order to do the standard deviation, I need to take the square root of something, and it says, okay, take the individual data point, whatever that is. All right, so my individual data point, let's just start with the top one, 116. So I'll do 116 minus 108.6, right? And then I'm going to square that number. Plus, because that's what the E means, you sum up all of these. There's more than one point. So that means I've got to do it with the second point. That's a 97.9. 97.9 minus 108.6, square it. Plus, parentheses, I go to my next data point. That's a 114.2 minus 108.6, square it. Plus, another data point, 106.8. And then finally, my next one is 108.3. All right, so I've taken the difference of all of those terms, squared them, and now I'm going to add them up. And then I'm going to divide by the number of terms that I have, the number of individual data points. So I've got 1, 2, 3, 4, and 5. So down here at the bottom, it's going to be a 5 minus 1. Okay, so that's a lot of math, right? That means in the calculator, what I want to do here is I want to take 116 minus 108.6 and hit enter. That's not right. 116 minus 108.6, and I get 7.4. I need to square 7.4, not times it by 2. That's raised to the exponent of 2. So on your scientific calculator, you will have something that will say a square function, caret 2 maybe. It might look just like this here. That's the square function on the computer. So what that basically is doing is it's taking 7.4 and it's multiplying it by itself again, 7.4. So 7.4 times 7.4. It's 54.76. All right, so 54.76 plus, I do it with my next set, 97.9 minus 108.6. Hit enter. I get a negative 10.7. Then I'm going to square that number, and I get 114.49. Notice that all negatives turn into positive numbers when you square them, so you will never have negative numbers during the step. 114.2 minus 108.6, and then I'm going to square that number. That gives me 31.36. Plus, still not done, 106.8 minus 108.6, and then I square that number. That gives me 3.24. Plus, and then finally, 108.3 minus 108.6 gives me a negative 0.3. I then square that number, and I get a 0.09. And then I need to add all of those numbers up and divide by 5 minus 1, which is 4. So I'm going to come over to the side and do 54.76 plus 114.49 plus 31.36 plus 3.24 plus 0.09, and I hit enter, and I get 203.94. I'm going to divide that by 4, and that gives me 50.99. Be careful, because this is the square root of all of this mess. So it's really the square root of 50.99. And on the calculator, you maybe, if you're lucky, will have a square root symbol. If you do, great. Do square root of, and then type in 50.99. If you do not have a square root symbol, but you have an exponent symbol, well, the easiest way to do this is raise it to the 1/2 power. All right? So on this scientific calculator with the computer, if I do x to the y, it's going to ask me, okay, well, what is your y? And that is a 1 divided by 2. Close the parentheses up, which is a 0.5, and then you're going to hit enter. So this gives me 7.14. So 7.14 is going to be the standard deviation. This is a very high number, which means that these numbers are not close together. And I know by looking at the data set that the numbers are not very close together. And this is the mathematical way of showing what the standard deviation is. All right, well, Excel will allow you to do the standard deviation as well. You saw how long that took. You know as good as well as I do that we do not have people in the lab that do this all day long by hand. We allow data sheets and Excel spreadsheets to do it for us. So what we do is just like before. You start off with equal because you want Excel to do the standard deviation. And you type in, what was my abbreviation? STDEV, standard deviation. And then I open the parentheses up. Now there's tons of different standard deviation versions. The one that I want you to do, though, is just simply STDEV with nothing else after it. All right? So STDEV, open the parentheses, click and highlight the data that you want it to do, and then you close the parentheses back and you hit enter. and you're going to get 7.14. It did all of that by hand, that you did by hand, all of that within a matter of fractions of a second. So this is by hand how you would do standard deviation. Individual data point minus the average, square it. Go to your next data point, minus average, square it. Next one, minus the average, square it. And keep going on and on and on until you take care of all of the numbers. And then you divide that by n minus 1. So in this case, we had 5 data points. 5 minus 1 is 4. So that ended up with 50.99. We took the square root of that number, and we ended up getting 7.14. Again, if you want to shorten this down because you don't like those number of decimals, up here at the very top, you will see the option that says decrease your decimal. So we can click that button and make it shorter if we want to, and report only 7.14 instead of 7.14 blah 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 blah. Okay? So there's the story with standard deviation. Again, it looks maybe a little nasty, prim and proper in a textbook, but if you know what those variables mean, it's basically telling you what to do. You add up the difference of the data point minus the average that's getting squared, and then you divide that by n minus 1, number of data points that you have, and then you take the square root of that total. And when you do that, that is by definition standard deviation. That is the horrendous way that it looks on a sheet of paper, and this is the much friendlier Excel, you've been a good boy or you've been a good girl version. Because I love you, you can do all this math for me. As far as Excel goes, a matter of seconds to do a standard deviation calculation. The good thing here is that Excel will come very powerful if we have a data set of 20 or 30 measurements. Could you imagine trying to do 20 or 30 measurements by hand with standard deviation? No, it would take me forever. And sooner or later, I'm going to mess up in one of those calculations because I've got to do 20 differences, square the differences, add those 20 differences up, divide by n minus 1, and then take a square root. And you're going to trust me to do that by hand? No, sorry. I don't even trust myself to do that by hand. I let Excel do it for me. And that's the purpose of us using Excel, which is why we want you to use it as much as you can, because it comes as a very powerful tool in a laboratory. All right, so that's 3 statistics down. We've got mean, we've got median, and we've got standard deviation. And there's many more to come. So stay tuned for part 2, the sequel.